solution, but we also did some comparison of different types of urban surroundings. So, for that purpose, we used micrometeorological data in order to get detailed information in terms of spatial and temporal resolution. And to obtain this kind of meteorological data, we used mobile weather stations. We used two micrometeorological carts that are considered to be state-of-the-art instruments, and they're like a sibling from ASU Marti that is developed according to after the development of ASU Marti. But we also used some low-cost instruments, and also we supported those data with remotely sensed data from Landsat satellite. So the study area is, of course, Novi Sad. It is the city in southeastern Europe. It is the medium-sized city that is about 100 square kilometers of built-up area, and it is also it has a population of 350,000 people. So this is the measurement setting. As you can see, we have there two micrometeorological carts that we didn't call Marti. And we also use these Kestrel instruments that supported this campaign of ours, and also used Landsat remote sensing images. The thing is that even though we conducted this campaign last summer, we didn't analyze all the data. So today I'm going to present more of the idea of the work that will be published in future, and some initial results from the micrometeorological cart measurements. So the campaign was organized like this. So we had 4 field measurements on sunny and hot days, and also in warm and sunny cloudy days. This campaign, we actually had one Marti cart that was staying in one place in the urban square, which contains no greenery and is in the open space. And it served as a reference location. And we had the other Marti cart that we moved around in a different location. We had about 50 location covered. So these were the different locations: urban squares, urban canyons, street trees, urban park, river, quay. We also had one small lake, overhangs, breezeways. So different types of surface, different type of surrounding, and different type of top covers. And the first results that are obtained are that in the morning and the midday periods, we have very, very low differences between the locations when you look at the air temperature. So in the evening period, that lasted from 6 to 9:30 p.m. We actually saw that there are some higher differences in air temperature between locations under tree and under the urban lake when you compare it to the reference location, which was in the urban square. Open locations in the urban park were less, they showed less difference of about 0.5 degrees Celsius. When we talk about globe temperature, then the difference in the morning were lower, but going to the midday period, they were a bit higher, up to 16 degrees Celsius. And in the midday period, the highest differences were between the breezeway, as you can see in this photo, some canyon that has overhang, but where the circulation of the wind is stronger. This was the higher difference in terms of globe temperature. Also, pocket parks showed some difference, which goes from 14 to 16 degrees. Under single trees, the value is a bit lower, 10 to 12 degrees, and in the open locations above the grass, they are 8 to 9 degrees. Solar radiation, and here we talk only about this shortwave radiation from the Davis device. As you can see, we here have one Davis meteorological station, but we also have these three Hooks-Flux sensors that can catch the radiation for all four sides of the world, but also from the above and from the ground. But we didn't analyze them now, so we only have these results from the Davis station. And of course, during the midday period, the differences were the highest. And the breezeway also had the best performance. Also, Urban Canyon also showed very good performance. Single trees also had a bit lower, but also significant performance. So similar solar radiation values are obtained for all open spaces, which is also something that we already expected. So these are some preliminary results, but we still have a lot of work to do. So the next steps are to analyze the short and long wave radiation from 6 directions from our Hooks-Flux sensors, but also to analyze and calculate TMRT and some of the thermal comfort indices, but also to analyze the surface temperatures from the Landsat images, but also from our sensors. What we wanted to achieve with this campaign is to actually analyze the thermal and biometeorological conditions, also to identify cool and cold spots in the city, and also to quantify the cooling potential of the different mitigation strategies during the hot and summer days. The results will contribute also to development of heat response and to some development of the new mitigation strategies. As you saw, if you were in the morning session, Professor Savic already presented some of the strategies that are also developed by our university. So this is what we want to complement with analysis and to provide the data from this installed nature-based solution that we are doing. Also, we are planning to do nighttime campaigns and also winter campaigns that are planned to be done in this year. Of course, it would be nice if someone would get involved and to do some other work in other cities, so we can compare the results and maybe find some similarities and differences, that we can have some comprehensive image of the cooling potential of multiple solutions. Thank you very much for your attention. Here is actually the email from my colleague Dragan, who should have presented this presentation, and also this QR code where you can find some basic information about our group, so you can get involved if you want, or contact us for some project or work together. Thank you very much.
Thank you. We have time for questions.
Thanks for the great presentation. It's nice to see that Marty has an international family. On the cart, you've got a globe thermometer and then 3 Hooks-Flux pyranometers and pyrogenometers. Yeah. So are you, for mean radiant temperature, are you planning to calculate it from the globe and from the pyranometers and geometers and then compare?
Yes.
Or,
Yes, we will do that because we have a lot of data obtained with the Marty, of course, but we will for sure make some comparison to see which sensor gives maybe better, or are they similar, but I think they are similar from what we saw from the data that we obtained already, but I didn't present it because they are not actually analyzing that yet.
Yeah, it would be fantastic to see some more published data of field studies with simultaneous globes and radiation instruments, and especially at night as well. That would be really great to see.
Yeah, we actually did nocturnal campaigns in this year, summer 2023. So, okay, if we work hard, then we will have the results.
Well done.
Yeah, thanks.
More questions? Yeah, please.
Just a quick question about the orientation of Marty. Does that make a big difference on proximity to a building or the actual compass direction you set it up at?
Yeah, for the open locations, we didn't actually pay much attention about the orientation of the marquee, but for some locations that were very close to the wall, we actually tried to be 1/2 of a meter away distance if we wanted to catch the radiation from the building. But that actually wasn't possible everywhere because there was some very narrow holes. So I think somewhere it was even closer.
Yeah, during these measurements, we always focus that the Hooke's reflex who is down and up, it's the main sensor, and it should be somehow in the middle. But also others too, because they are oriented as southeast and others, should be also very useful for the radiation from the walls. But we are not really sure how far should be, according to some analysis. We will see during the analysis of the data that does we make somewhere mistake or we should orient it differently. But yeah, it's 1 meter, 2 meters, or should be closer. We are not sure according to the walls. Maybe some other experiences should be also good.
Yeah, if I can comment on that quickly. If you're trying to represent the radiant load experienced by a human, and you have one, the north-south radiometer close to the wall, and then the east-west is on the other end of the metal pole, if that's 1.5 meters or something away from the wall, then yeah, it's not approximating a human body so well.
Mm-hmm. Okay. Thanks. Okay.
Thank you.
Thank you. If no questions, we will move